Permitting sustainability. I'm going to quick share an overview of 3 serious problems that your jurisdictions may or may not be considering, and then a suite of promising solutions, which unfortunately cannot easily be permitted. And that'll set up this panel on how to permit these and other solutions that our times are calling for. So it turns out separate bureaucracies are in charge of structure fires and forest fires. And cities burning like forests falls into the crack between these bureaucracies. So this is the first problem, is whole cities are now burning down at once, and there's no agency responsible for this new hazard. Paradise, California is patient zero for this problem. Consider just the water provider's predicament. 90% of the ratepayers' houses are gone, as well as their employees' houses. And they've got things to deal with, like 64 miles of plastic distribution mains, which were dewatered, overheated, and now permeated with toxins. There's never been anything like this before. No agency knows what to do. There's limited prevention resources for this new hazard, response, or even tracking. I compiled this graph with all the data that I could find on structures lost in wildfires. There was this graph of structures lost nationally in the United States, and I believe this is the first time anyone will have seen a graph of California losses. I found the data from CAL FIRE, and that's our contribution to the national losses, and yeah, that's the last 2 years. So this hazard's emerged so rapidly that we've not adjusted at all with our codes and practices. And what's more, fire scientists are saying this is just the warm-up. They're saying that all of California forests are going to burn down, maybe not come back, and take a lot of the houses with it. This wildfire, cities burning down issue is an illustration of the second problem, which is that foundational design assumptions that have been constants for lifetimes, just not changing, things like mean sea level, flood and drought recurrence interval, urban firestorm threat, are actually now variables. So the foundation for our infrastructure is design assumptions that are no longer valid. We're like Wile E. Coyote that hasn't looked down to see that the foundation of our structures and infrastructure is dissolved. For example, for firefighting, as we've known it, this does not scale when thousands of structures are threatened at once. There's just not enough trucks, water, or firefighters. So how could we adapt to these rapidly changing conditions? Well, that's the third problem. There's no regulatory framework for innovation. It's literally illegal in California to permit anything that is not in the current code. So if you want to come up with the basis for new codes, there's no framework for that. So you might ask, where did Greywater, Solar, Straw Bale, our marquee green codes in California, where did these all come from? Well, citizen innovators did all the R&D without permits. And without benefit of a formal framework, these new practices take decades to get into code, and quality suffers both for the practices and the codes. So clearly we need a new system to scout responses to these rapidly changing conditions. Here's this suite of promised solutions on helping cities from burning down based on my 20 years of work in this area. First, a fully integrated approach to both forest and structured fires, building, landscaping, water systems, all of it integrated and optimized at once. Second, non-combustible construction, for example, monolithic adobe for new structures. And this non-combustible construction is equally resistive, regardless if 1 or 100,000 of these buildings are threatened at once. So this non-combustible construction is a key element, and this is something that's just newly available based on work that I'm going to share with you in a moment. Third element is ultra-high efficiency water fixtures, alternate supply, and reuse. That enables you to downsize water connections by 80 to 95%. We're down to well below 10 gallons per day per capita at our house, and we haven't even implemented all these best practices yet. That leaves water in the mains for low pressure, low volume, automated exterior misters that are sized to the distribution main capacity. Those could be automated so that they turn on the whole side of a city towards the fire and then shut off automatically as the fire front moves on. Would this work? Well, who knows, but I'd love to be able to get a permit to be able to try some of these elements out. It's certainly better than the current mandate, which is high volume interior fire sprinklers. These are great for a structured fire, but leave water systems dry in a firestorm. So water providers, I suggest that you consider how much water structures leak when they burn and calculate how this will affect your network. And to get you started, I did a kind of simplified case here. Out of 100 homes exposed to a firestorm on an 8-inch water main, if they're bleeding out through 5/8-inch meters, about 90 of those 100 would burn based on the Paradise experience. And that's a 2,500-gallon leak, and it would leave 46 psi in your main. With modern fire-resistant construction and interior fire sprinklers, only 50 of them would burn, but the sprinklers are connected through 1-inch fire lines, so you'd only have 0.3 psi of water left in your 8-inch main. If you were to do the non-combustible construction that we're recommending, we're estimating that 10 or maybe even fewer would burn, and that would leave almost the full 100 psi in the water main. So how fire resistant is monolithic adobe? We did this 4-hour test where we burned 2,000 pounds of firewood at 1,800 degrees against the wall for 4 hours, and the heat never reached the backside. And then this big shift is we just got engineering values for all seismic zones in California, and that removes a major impediment to permitting. So what about water resistance? Here's a video of a centuries-old adobe resisting the El Capitan debris flow as a wooden structure floats by. And this thing was filled with mud inside and out for days, and it survived and is still there today. Combustible and toxic materials, or non-combustible, non-toxic fire break structures. Alas, this new best practice is almost impossible to permit with current codes. We're a year into permitting on our Ortega demonstration project. We can get a stamped rational engineering judgment saying that the walls would have a 6-hour fire rating, but there's an inflexible code requirement calling for a very specific $40,000 test to say that it has a 1-hour rating, and it would take 6 months for us to do that. So that's just one line of a 1,000-page checklist, which leads us to the second solution in the subject of this panel, which is local flexibility to permit needed new best practices. Flexibility that would allow pilot projects, faster, higher confidence R&D with direct collaboration between innovators, policymakers, regulators, and researchers, limited scale adoption, sensible scaling up as these new best practices are proven, and then ultimately pre-approved plans for mass permitting of fire-safe structures when 10,000 houses need rebuilding at once. Thanks.